Why is this planet, which is clearly so perfect, making scientists more and more uneasy? It doesn't lack sunlight. It doesn't lack warmth. It might even have liquid water. It almost fulfills all our fantasies of a second Earth. But the more it's studied, the more something feels off. Its size exceeds the upper limit for a rocky planet. Yet it isn't bloated like a gas giant. Its position is perfectly situated in the habitable zone, but it has no moons, and no known companions. Every detail about it seems like some kind of artificial design. Not a coincidence, not an exception. It's as if the universe, after repeated adjustments, produced this final version. It seems as if it wasn't naturally formed, but was manufactured. This is Kepler-22b, a planet that shouldn't exist, yet has become the most watched target in the astronomical community. What we're going to do today is not to simply introduce its parameters, but to break down its anomalies and see what hidden information it might conceal. The discovery of Kepler-22b originated from an astronomical experiment that was like a gamble. In 2009, NASA launched the Kepler Space Telescope. It doesn't take pictures. It is only responsible for staring at 150,000 stars in the Milky Way, waiting for subtle changes in their brightness. Why do this? Because when a planet passes in front of its star, it will slightly block some of the light. This method is called the transit method. It sounds simple, but it's incredibly difficult in practice. It's like lighting a candle 100 kilometers away, and then sitting at the foot of a mountain, staring intently at that point of light, waiting for a mosquito to fly past it. What Kepler needs to capture is this 0.01% change in brightness. And it has to see the exact same pattern 3 consecutive times to confirm that it is indeed a planet. What's even more difficult is the orbital planes of most exoplanets are not aligned with our line of sight at all. They will never appear in front of their star for you to see. So, what Kepler can see is just a small handful of planets that happen to transit, and Kepler-22b, in this low-probability gamble, was the miracle that was precisely captured. It orbits a sun-like star, Kepler-22. The telescope discovered that this star's brightness dips slightly every 290 days. Each dip is 0.01%. It's as if a regular, transiting object is just grazing its edge. After 3 transits, scientists realized this might be a planet. But transit data alone wasn't enough. They spent 2.5 years using multiple ground and space telescopes to repeatedly check for all possible errors, ruling out interference from binary star systems, and false positives. In 2011, NASA officially announced the confirmation of Kepler-22b. It was the first confirmed exoplanet in the habitable zone of a sun-like star. This wasn't just the discovery of a planet, it was the confirmation of another world, where life could potentially exist. From that moment on, space exploration entered a new era. Kepler-22b is 600 light-years from Earth, orbiting a G-type star, very similar to our Sun. It completes one orbit in just 290 days, with an orbital distance of 0.85 astronomical units, placing it perfectly in the Goldilocks section of the habitable zone if it has an atmosphere similar to Earth's. Its surface temperature could be around 22 degrees Celsius, which is the most comfortable spring-like climate for us humans. This sounds almost too perfect to be true. But the more perfect it is, the more abnormal it seems. This planet's radius is 2.4 times that of Earth, and its density is still undetermined. It's too large to be a rocky planet, yet too small to be a gas giant. It falls right into what is known as the ambiguous range of the Fulton Gap, a place where, according to theoretical models, planets should exist. Our solar system has no planets of this size. If you had to make an analogy, it's like seeing a gorilla that is 2.4 meters tall, but whose musculature doesn't fit the expected structure of a gorilla. You wouldn't know what category of creature to put it in. What's even more strange is that its orbit is almost a perfect circle, with no eccentricity. There are no visible perturbations. It's as if it was placed In the star's golden orbit, after precise calculations, it has no moon, no companion star, and no other planets have been found orbiting the same star. The entire system is unnaturally clean. When scientists examine its light curve, they feel it doesn't seem like a real planet. It's more like a standard sample running in a cosmic simulator. Sometimes, being too ideal makes something seem less like a natural product. And precisely because we have no clue about its composition, it has become one of the hardest planets to define. It could be a rocky planet, a gas giant, a water world, or it could be some kind of new type that we have conceptualized before. So, what is it, exactly? Scientists have proposed 4 hypotheses. Each one is like an attempt to explain a mystery, but none of them are completely convincing. The first hypothesis: it's a rocky super-Earth, enveloped in a thick atmosphere. This is theoretically plausible, but the thicker the atmosphere, the higher the temperature. If it evolved like Venus, its surface could be a perpetually boiling pressure cooker. But if the atmosphere isn't thick enough, then its size cannot be explained. After countless simulations, it's always stuck at a critical point of being neither hot enough nor cold enough. It's as if it's been tuned to 99% by some invisible hand, but can never reach 100%. The second possibility: it's an ocean planet, completely covered by a global ocean, hundreds of kilometers deep. Sounds fantastic, doesn't it? But with no continents and no geological activity, there would be no nutrient cycle. Even if microbes existed, they might forever remain in their most primitive state, unable to develop a biosphere. This would be a planet that looks very blue, but it might just be a sterile water world. The third possibility: a mini-Neptune. It might not be made of rock, but a small-scale gas planet. But here's the problem: its orbit is too close to its star. Not at all where a planet of this type should be, unless it initially formed further out and was later dragged in by something. Then what dragged it in? And what force allows it to maintain perfect stability in its new orbit? The fourth hypothesis: it's a composite planet with a hybrid structure, possessing a rocky core, a water layer, and an atmosphere, forming a multi-layered composite. Simulations show that such a structure could theoretically exist, but its evolutionary path is extremely complex, requiring incredibly precise initial conditions. In our known evolutionary models, such an outcome simply doesn't emerge. Every guess circles back to the starting point. Every model feels like forcing reality into the cracks of a hypothesis. So the question becomes, could it be that our models are wrong? Of course, scientists are unwilling to accept the idea that our understanding of the universe is wrong. Their initial reaction was to question the data. So they checked the instruments again and again, compared spectra, analyzed the orbit, eliminated noise, ruled out false positives, and eliminated all possible artifacts. But the results of the check led to only one conclusion: it truly does exist. Some have also proposed that it might have originally had companion planets, but later lost them due to some cataclysmic event. But the Kepler-22b system looks to clean. There is no debris, no orbital interference, no trace left behind of a past catastrophe. It's like a newly renovated laboratory that has been cleaned spotlessly. So, the question is, why does it exist? Why? Does it happen to fall perfectly within the optimal range of a series of parameters? This planet has shattered the classification system we built based on our solar system. It's not like any planet we are familiar with. Yet it happens to have all the potential for habitability. Its existence forces us to admit a fact. Perhaps the logic of planets as we understand it is merely a special case, not the general rule. And what's most goosebump-inducing is that not only is its composition abnormal, but it also hits all the marks so perfectly. Its radius is exactly to point for times that of Earth, right on the edge of the Fulton Gap. Its orbit is perfectly within the habitable zone. Its orbital period is very close to an Earth year. Its theoretical temperature, assuming it has an atmosphere, is exactly the 22 degrees Celsius most comfortable for humans. A series of just rights. If it happens once, it's a coincidence. Twice is luck. 3 times, 4 times, 5 times ... that becomes suspicious. Of course, we can't rationally say it was manufactured. But if a planet looks like it has been artificially tuned into a sample planet, then we have reason to ask, was it never meant for us to see? Is it an invitation? A reminder? Or a specimen in some kind of cosmic experiment? It may not provide us with answers, but it forces us to ask new questions. If the universe truly left behind such a sample planet, could it be trying to tell us something? Or, to ask more boldly, if a planet looks like it was manufactured, then what about ourselves?